Students, today this is our vectors. So there are many formulas in vectors. I prove it one by one, like what will be a vector plus b vectors whole square form. So we will write down this in this way: a vector plus b vector multiply a vector plus b vector a vector multiply a vector plus b vector multiply a vector multiplying a plus b vector with a vector square dot square product satisfy distributive law and commutative law both. Square product satisfies distributive law and commutative law both. That's why we can do this with a vector, the distributive law, plus with b vector plus b vector b vector. Now we can write down this as a vector whole square. Here we can write down, since square product satisfies this commutative law, so we can write down this as a vector multiply b vector plus a vector multiply b vector plus b vector whole square. So this will be a vector whole square plus, we can add up this, so it will be 2 into a vector b vector plus b vector whole square. Similarly, you can prove this, that a vector minus b vector whole square will be a vector whole square minus 2 a vector b vector plus b vector whole square. And the third formula is similarly a vector whole square minus b vector whole square is equal to a vector minus b vector b vector. So here we introduce a vector plus a vector b vector, and we introduce a vector b vector minus a vector b vector minus b vector B vector. So if we know that square product satisfies distributive law, so it will be A vector plus B vector, and here it satisfies also commutative law. So you can write down B vector A vector minus B vector multiply B vector. It will be A vector and B vector in a bracket. Here it will be B vector and a bracket A vector plus B vector. Now again it satisfies distributive law, so we have A vector minus B vector, and here it will be A vector plus B vector. So this is our theorem that A vector whole square minus B vector whole square is equal to A vector minus B vector plus is multiply A vector plus B vector. So how we can prove this? That distributive law is satisfied by square product. Distributive law and commutative law first improving two number commutative law. How we can prove that square product satisfies commutative law? If we take A vector is equal to x1 I cap plus y1 I j cap plus z1 k cap, and B vector is equal to x2 I cap plus y2 j cap plus z2 k cap. Then A vector dot B vector is equal to x1 x2 plus y1 y2 plus z1 z2, and B vector A dot A vector will be same x2 x1 plus y2 y1 plus z2 z1. So you can look this, both are same, so we will have A vector dot B vector equal to B vector dot A vector. So square dot square product satisfies commutative law. So this satisfies commutative law, and one number will introduce vector C vector we are taking x3 I cap plus y3 j cap plus z3 k cap. So we will have a dot a vector dot b vector plus c vector is equal to a vector and here it will be in first bracket x1 plus x2 x2 plus x3 I cap plus y2 plus y3 j cap plus z2 plus z3 k cap. Now if I put the value of a vector, then we will have x1 x2 plus x3 plus y1 y2 plus y3 plus z1 z2 plus z3. If we rearrange this, we will get x1 x2 plus y1 y2 plus z1 z2 plus x1 x3 plus y1 y3 plus z1 z3. This will be a vector, b vector plus a vector, c vector multiplied dot c vector, a vector dot b vector, a vector dot c vector. This is our distributive law. This is our left distributive law. This is the left distributive law. And to prove the right distributive law, we will go in this way. The right distributive law is that a vector plus b vector dot c vector. So here it will be x1 plus x2 I cap plus y1 plus y2 j cap plus z1 plus z2 k cap into c vector dot c vector. If we put the value of c vector, then we will have x1 plus x2 multiply or dot x3 plus y1 plus y2 y3 dot y3 plus z1 plus z2 multiply z3. Now we can write down x1 x3 plus first multiplication is just y1 y3 plus z1 z3 plus x2 y3 plus y2 y3 plus z2 z3. This will be a vector c vector plus b vector dot c vector, a vector dot c vector plus b vector dot c vector. So it is a right distributive law. So it satisfies right distributive law also. So overall scalar dot satisfied distributive law. Again, if you like this video, the like. If you have not subscribed, then subscribe. So how we can prove that two vectors are parallel? How we can find two vectors are parallel. So here we know that a vector dot b vector is equal to mod of a vector multiply mod of b vector multiply cos theta. Theta is the angle between these two vectors. So if two vectors are parallel, theta will be 0 and cos theta will be 1, or cos 0 will be 1. So then we have a vector b vector is equal to mod of a vector into mod of b vector. So this is the condition required to prove that two vectors are parallel. And I earlier proved that how two vectors are perpendicular to each other. We will last prove a vector whole square plus b vector whole square. We have to prove. We take a vector multiply a vector plus b vector multiply b vector. We will take here a vector by a vector plus 2 a vector b vector plus b vector multiply b vector minus 2 into a vector multiply b vector. So here you can take plus minus and minus plus. So you can break down this in this way: a vector dot a vector plus minus a vector multiply b vector plus minus a vector multiply b vector plus b vector multiply b vector minus 2 into minus plus 2 into a vector multiply b vector. We take common or use left distributive law. We have a vector plus minus b vector plus minus and we take right distributive law, or we can use commutative law. B vector multiply a vector plus b vector minus 2 minus plus 2 a vector b vector. So what we will get, we take common here b vector it will be a vector plus minus b vector. We can take right left distributive law again using, so it will give a vector plus minus b vector square minus plus 2 into a vector b vector. This is our another formula. We can use algebraic formulas or establish algebraic formulas in scalar products, and can prove this through commutative law and distributive law.